Hello everyone. Okay, so what we are going to discuss is the inventory management models where the demand is not constant. As you already know, whenever the demand is constant, the commonly used inventory management model is the economic order quantity model. Right? So, economic order quantity model, we know that we need to apply only when the demand is constant. And we also apply this when the lead time is also constant, right? So this is the condition under which we apply this particular economic order quantity. Now, the situations under which when the demand is not constant, when we say the demand is not constant, that means that let's say we take a 5 week period, right? In a 5 week period, the demand in each week, 1, 2, 3, 4, 5, happens to be different. Let's say, for example, in the first week it is 10, the second week is 20, the third week it is 15, and fourth week it is 20, again fifth week is 10. So it is clearly showing that the demand is not constant. Now, this in such kind of situations, whenever the demand is not constant, automatically it brings in the concept of variability, right? When we say variability, we are interested in two aspects. One is we are looking at the mean of the data, which is the demand data, and the standard deviation or the variance of the data. Right? So this is what we are looking at. Now, whenever we look at inventory management models, especially when we try to understand how demand for a particular product works, we can have different types of distributions of demand. Now, the whole point of distribution of demand means that whenever there is a variability, we want to understand whether there is a pattern to that particular variability. Now, what we mean by pattern to the variability is that uh, can we look at the histogram or the frequency distribution of the demand and find a pattern to it, right? Now, what these patterns help us is that they give certain special properties to the mean and standard deviation, which we can use to further apply in the case of analyzing what should be the right amount of inventory. Now, if you remember from the point of what we had discussed in operations management, whenever the demand is uncertain, when we say uncertain, it is the same thing as not constant or variable. We generally look at two types of inventory management models. One is what we call as the continuous review model, and the other one is what we call as the periodic review model. Continuous review model is, as the name itself suggests, is where we are continuously reviewing the inventory. Here we are continuously reviewing the inventory. Now, when we say we are continuously reviewing the inventory, what it means is that there is a system which is looking at what is the inventory at any point in stage as the demand keeps coming in and the inventory keeps depleting. What is the current amount of inventory that we are holding? And is that inventory sufficient enough to meet the demand? Right? That is what this continuous review model says. In a periodic review model, as opposed to this, we are not continuously reviewing the inventory, but we are only periodically reviewing the inventory. We are only periodically reviewing the inventory. And when we are periodically reviewing the inventory, there are chances that we might be in a situation where there is a sudden demand which might come and which can exhaust all the inventory which is there in your warehouse. Right? So in such kind of situations, how do you handle this kind of demand is what these two inventory management models kind of explain. Now, in the continuous review model, in the continuous review model, we keep answering the same two questions that are of importance to us, which is what we refer to as the how much to order and when to order, right? We are still trying to answer to the question how much to order and when to order. These are the two main questions that we always try to find answers for. The assumption is that you also know what to order and what are the different types of products that you have. You decide on what to order, right? Now, going back to this particular discussion of continuous review model, the whole concept that we mentioned is that we are continuously reviewing our inventory. Now, as opposed to what happens in economic order model, where we know that in an economic model, we always know that the demand is going to be constant like this, and we are always trying to measure up that the demand is going to be similar, always going to be a kind of a triangle, similar triangle like this, right? Now, that is not the case when we talk about the case of continuous review or periodic review, largely because we are talking about cases where the demand is not certain. So the moment we are saying the demand is not certain, we are not going to end up with such nice triangles, because those triangles represent that the demand is constant. And in the case when the demand is not constant, you're not going to have a nice sloping line which is going down, right? So what we are going to have is a squiggly line which might look like this. So where the demand might be high at some one point in time, and demand might not be, demand might be low at another point in time. It means to say that if we take a 5-week window or a 5-day window, you might have a very high demand on one particular day, and you might even end up having zero inventory on the other day. That is the focus there, right? Now, in such kind of situations, what does a continuous review do? A continuous review is always looking for how much do I stock such that I don't end up in a situation where I might lose my demand, right? Now, the whole point of when we are in a situations where we will probably have a stock out is or also to say when will we have a situation where we will not be able to meet the demand is usually during the lead time. Now, what does lead time mean? Lead time means that from the time we place an order till the point we receive the order, what is the time that is there? So imagine we are placing an order at this particular point in time, which is where we have what we refer to from what we know from economic order quantity, a situation called as a reorder point. Now imagine this is this point where we place an order, and it takes lead time, or L as the lead time, number of days or weeks for us to get back our inventory. Now, it might so happen that in this particular period, the lead time, the demand can be anything. There could be large amount of inventory, or there could be very less amount of inventory, which can be probably shown like this. Now, as you can see over here, we are saying in this particular instance, we are saying that while the demand is uncertain, we are able to get the inventory exactly by the time this particular inventory is going to go to zero. And the assumption that we are making again over here is that there is instantaneous replenishment that is happening, and then there is inventory which is getting depleted like this. Right now, imagine we hit this particular reorder point again. Now, what could happen from here is that the demand could be very, very high, which would mean that suddenly the demand drops like this immediately, zero, and it might even go down, which means that there is stockouts. Or we might have a situations where this particular squiggly line is very, very flat for the lead time amount of days. That means that by the time we get our next shipment, we are still having a significant amount of inventory that is left. So these are different situations, and the other situation could be something like this, where we are exactly ending at 0, right? So there are multiple such situations that could happen from the point where we are hitting our reorder point. That's what this wiggly line with different slopes is representing. You can go back and refer to the diagrams which are mentioned in the PPT that is shared with you. You can clearly understand what does this exactly mean, right? Now, once we understand what is happening over here, let's try to now look at how do we answer this particular question, that is how much to order and when to order. Now, as is the situation over here, the optimal policy is that the answer to the question how much to order happens to be the economic order quantity, which is not any different from what we had discussed earlier in economic order quantity video, which is nothing but under root 2 ds by h. So you understand how do we calculate D? D is the annual demand, S is your setup cost, H is given by H is equal to IC, where I is the carrying cost and C is the cost of the product. You can go back and refer to the EOQ video for you to understand more about this. Now, the more interesting part is the answer to the question, when to order. Now, when to order happens to be calculated using the reorder point. Reorder point is arrived at using this particular formula, which is mean demand during lead time plus the safety stock. Now, what this particular thing means is, for us to understand this particular thing, let's go back to this example, right? This example of the five week that we have looked at. Now, if you look at this particular example, we have situations where the demand could be 10, 20, 15, 20, and 10. Now, let's look at the mean of this particular thing, right? So this is 40, 50, 60, 75. So if I take an average of 75 divided by 5, I will get the value of 15, right? Now, if I take 15 as the mean value, let's assume that this particular thing, let's assume the lead time also happens to be one week, right? And if you look at this particular aspect, that is mean demand during lead time, I am assuming that my mean demand in this particular case is 15. Now, if you look at this, if I keep an inventory of 15 and I end up having the demand as 10, I'll definitely meet the demand over here. If I keep the demand, if I keep my inventory 15 and the demand happens to be 20, I will not be able to meet the demand. Now, in this case, again, I will meet the demand. If I have 20, then I won't. And here again, I will meet the demand. Now, you can clearly see that when I'm having the mean demand during lead time, there are at least two situations where I'm not able to meet the demand. Now, if I continue doing this for multiple weeks, you will see that there are situations where you are able to meet the demand and there you are in some cases where you are not. Now, one of the assumptions that we make when we are trying to work with this particular continuous review model is that our demand follows normal distribution. Demand follows normal distribution. Now, what is the meaning of demand following a normal distribution? The demand following a normal distribution means is that if we have multiple demand values for multiple weeks, if we calculate that particular thing, and if we look at the distribution, which is largely coming, this distribution means the probability distribution, which we understood is largely coming from the histogram, which is again the concept of frequency distribution, right? Now, if you look at any particular data and try to understand its particular histogram and try to see how it looks like, then depending upon what kind of shape that you get, you will assume whether it follows a normal distribution or not. Now, this normal distribution, as we discussed above, is one of those shapes of that variability of demand data, which makes our life much simpler to work with. Now, it's not necessarily that your demand will always follow normal distribution. Now, in such kind of cases, what do we do? we'll try to understand that particular thing later. That is a slightly more advanced topic. But for now, let's assume that this follows normal distribution. Now, what does it mean to look like a normal distribution? Let's look with an example, right? Now, I am assuming that I have a particular data and my demand for this demand for a particular product over, let's say, 10 weeks kind of looks like this, right? So demand in, again, it's not necessarily that this is week wise. Let's assume that this is how the demand looks like, right? So it is maybe, so this is how the demand looks like. This is how the demand looks like, right? So this is what I have tried to portray. This is for 10 weeks, right? Now, when I plot the histogram of this particular data, you will see, well, okay, let me try to put the bin width as maybe 0.5. Okay. Let's make this. Something like this, right? So if you look at this particular data and imagine if I'm trying to smoothly join the midpoints of this particular histogram, right? So there is different amounts of demand that is there, and if I'm trying to smoothly join the midpoints of this particular thing, this might look like this, right? Read for the particular thing, it might look like this, right? So this is how it might look like. Now, for a perfectly normal distribution, what we were expecting is something like this. So we are expecting something like this to happen. Now, this is not exactly the normal distribution, but it might be considered somewhat close to it. Now, how close is it? How different is this particular thing? You can understand this using a particular technique called as distribution fitting to any particular data. Now, when you do distribution fitting, then you can compare it with certain data with respect to the chi-square values or the certain metrics such as AIC, BIC. If you are interested further, you can read about that particular thing called as distribution fitting. Now, if time permits in one of these sessions, when we discuss further, we might also discuss about that, right? So this is what having a demand which follows a normal distribution means. Now, just for you to understand this particular thing better, if I take an example of any particular data, let's say I'm randomly creating, let me randomly create the demand which is following normal distribution, and let me show that to you so that in this particular histogram, you can clearly see that this particular thing is much more close to a normal distribution. So what I did over here is I have randomly created about 80 data points of a normal distribution with a mean 5 and standard deviation 1, and which is what you are able to see over here. Now, if you try to kind of put the midpoints of all these bars of the histogram, you are able to see that it is following a normal distribution. Now, what is the difference between histogram and a probability distribution? Is that this particular thing that you are seeing over here is a frequency distribution graph. So it is literally saying that from the numbers between, let's say, 2.84 to 3.58, there are about 4 such instances. And here there are about 12 such instances. Here there are about 20 such instances. Here there are about 24 such instances, and so on. Now, 24 out of how many? There are 79 such total instances. So this is 4 divided by 79. If you want to actually put it from a probability distribution point of view, it is saying that there is only 5% chance that if a randomly picked number from this will fall between 2.84 and 3.58. That is what this particular thing is representing. Now we are going to use this particular concept of probability distribution to explain how we go about working with demand distribution or normal distribution in the case when the demand is uncertain, right? So now that we understand what it means for the demand to follow a normal distribution, if we have to represent the demand following a normal distribution, and this is how it will probably look like, right? So if I draw the normal distribution, this is how, this is, the base is always, think of it like your number line, right? On the left-hand side, you have negative numbers. On the right-hand side, you have positive numbers. So for any normal distribution, the ends are minus infinity and plus infinity. So if we take any particular normal distribution, right, something like this, then we are saying that the demand is following a normal distribution. What does demand following a normal distribution mean? That if I know that the demand has a mean mu and a standard deviation sigma, the demand could be anywhere in this particular graph with a higher probability around the middle region and lower probability on the either side, right? So that is what this particular thing is saying. As I mentioned, the bottom line is like a number line. Now, when the bottom line is a number line, let's assume that the demand follows a distribution like what we have shown over here, where we are saying that the mean value over here is 15. So let's work with that, right? So let's say the demand happens to be mu is 15. Let's assume that sigma is 5, right? Now, there were instances where the demand there was 20. There were instances where the demand was 10. So if mu is 15, 10 happens to be over here. And this is value of 10 and 20 happens to be over here. Now, if I take multiple such instances and not just 5 weeks, there could be multiple different values. One of them could be 12, one of them could be 18, one of them could be 23, and so on, right? So there are different values of demand which could be there. Now, if I want to work with, if I want to only represent the mean and standard deviation and just work with this particular thing, how I am going to look at this particular thing is that I want to meet as much demand as possible in a more economical sense, right? And that's where this reorder point comes into picture. Now, if I just keep 15, as I've taken the example over here, then I am only going to meet 50% of the demand, which is over here. So this is just 50%. Why? Because normal distribution has a special property that it is symmetric in nature. That means it has 50% on the left side and the 50% on the right side. That means 50% of the values are to the left of it. That is 50% chance that all the values in my data of demand will be 15 or less. And 50% chance that values are 15 or above in my demand data. That is what this is saying. Now, if I keep my reorder point at mean demand during lead time is 15, that means I have hit my inventory at 15. Now, before I get my replenishment from my supplier, which is during this lead time, I have 15 units of inventory that is left. Now, during this lead time, there could be any amount of demand that could come because we know that demand is uncertain. Now, given that demand follows this distribution, if I get a demand value which is 15 or less, I can always fulfill that. Now, what is the chance that we are going to get 15 or less? That is 50%. We can see over here. But what if the demand happens to be slightly more than this? What if it is 16? What if it is 18? What if it is 20 or 25? Then we are not able to meet that demand. Now, how do we meet that particular demand? The way to meet that particular demand is to work with this safety stock. Now, the safety stock is going to be the extra that we are going to add to this reorder point, which is going to increase our chances of meeting the demand. Now, one would always want to maximize the chances of meeting the demand. But if you think about trying to meet the 100% of the demand, then as we can see over here, the only way to meet 100% of the demand all the time is by having infinite inventory, which is practically not possible. It is not economical too. Now that is where we are going to go with a probabilistic approach that I will work with 90% of the demand, 95% of the demand, which is what we refer to and we have been working with as what we call as the service level. Now, this type of service level, which we are going to look at, is what we refer to as this cycle service level, right? So if we are setting a reorder point over here, which is not only the mean value, but also this extra safety stock, then there is a chance that we are going to go, which is 50% plus something, right? So let's say this is 40%. So that means 90% of the demand is met, 10% is still not met. Right now, that 10% is what we are letting go of. Now, why are we letting go of? Because we are thinking that the cost of not meeting the demand is much less than the cost of trying to meet that particular demand by having excess inventory. So sometimes you let go of that particular thing. Now, as you want to increase your service level, you go to 95%, 99%, and so on. Now, this particular thing, we have mentioned that as our cycle service level. Now, what does cycle service level mean? The number of times in a particular, let's say, 1 year period, 2 year period, when there have been instances of demand coming to you, how many times out of that total number of demand that you have experienced, were you able to meet the demand completely with your on-hand inventory? That is what your cycle service level represents. Cycle service level. You can also look at it as if you had 100 such instances of demand, how many such instances of that demand out of 100 did you meet completely with on-hand data, right? So this is the most important aspect to remember. Now, remember that all this particular thing again also means that we are only focused on this particular lead time because this is when the entire concept of your stock out happened, right? Now, if we try to understand from the basics of normal distribution, this part at the middle is the mu. But if I want to identify what exactly this is, now the good thing is, as we have mentioned above, normal distribution has some special properties that this particular value, if I'm saying 90%, this particular value can always be identified corresponding to a probability, right? So this particular thing is if I want to identify what is this particular point where the left hand side is 90%, that happens to be mu plus a z value which is corresponding to the 90%, which we refer as 0.9, or an alpha value of 0.1, which is 1 minus 0.9 multiplied by the sigma. Right? Mu plus z sigma gives us our reorder point. Now, the only difference over here is that when we write down the formula for reorder point over here, because we are saying that this is mean demand during lead time, and this is mean demand for any particular week, as we have calculated that this is for 1 week, right? So this is different weeks, and we have calculated the average as 15 for week, right? Now, what if the lead time is 2 weeks? So then in mean demand during lead time would be 15 into 2, that is 30. Similarly, safety stock also gets adjusted, right? Now, to work with, the more apt value or apt formula that I'm going to use is mu into L plus Z sigma root L. Now, this is the formula that we have been using for the reorder point, mu L plus Z sigma root L. The Z sigma is coming from there, and instead of just L, we are using root L. Now, why is this root L happening? Is because whenever we said that the mean demand in the above example for a week is 15, right? 15 units. Now, if we wanted to identify what is the mean demand for L weeks, we said 15 into L. Now, here, this is literally saying that we are adding multiple normal distributions. How many such normal distributions I am adding? I am adding L normal distributions, because for this particular normal distribution is for 1 week, right? But I need it for L weeks. So I am assuming that here we make an assumption that our demand is independent from 1 week to the other, which allows us to add these things, which is what we are seeing over here. So when there is L weeks of demand that is added, it becomes 15 to L. Now, why does that root L come? The root L comes because whenever we are adding such normal distributions, the means get added. So if this is mu sigma, this is mu sigma, and this is mu sigma, and so on, the corresponding value that we get for L such normal distributions is going to be another normal distribution which is having a mean L mu, right? And here the variances get added. So if this was instead of sigma, which is standard deviation, if variances are considered, then this becomes L sigma square. Now, if we say that the variance is L sigma square, we know that standard deviation is under root of variance, which is under root L sigma square, right? So this is under root L sigma. Now this particular under root L sigma is what is appearing over here, Z sigma root L. That's the logic behind this formula being this way. Now we have answered the question of what is the answer to the question how much to order and when to order over here, right? So this is how you are going to look at this particular thing. Now, this particular definition of reorder point, if you understand clearly, you understand that if I am keeping my inventory at this particular value, I will always be able to meet the demand which is to the left of reorder point. Whenever the demand happens to the right of reorder point, I will not be able to meet that. Now that is what we were discussing in the class, in the last class, as something called as expected shortage during replenishment cycle. Expected shortage during replenishment cycle is what we refer to as ESC, right? Now, what exactly is this expected shortage, right? So let's try to understand this. Now, is this draw a normal distribution of this, right? So this is my normal distribution, and we have this as our mean. This is the mean demand, and we have set our reorder point over here, right? And we said that anything to the right of this particular value, right of this particular reorder point, is something that I'm not able to meet, right? Now, if let's say the demand, let's say I'm setting the reorder point at 20, right? And let's go by the same example that we had. Mu is 15 and sigma is 5, and let's say reorder point is set it at 20. Now, if my demand happens to be 22, because I set my reorder point at 20, the shortage that I am going to have, this is the demand in one particular week, the shortage that I'm going to have is 2 units, right? Now, if the demand happens to be 26, because my reorder point is 20, in that particular period, the shortage happens to be 6 units, right? Now, because I want to identify an expected value is always calculated as the value multiplied by the probability of that particular value. Now, this happens when this particular thing and this particular thing are corresponding to what we call as a discrete distribution. For discrete distribution, the expected value, which is represented using E of x, is calculated as x into P of x. Now, why are we calling expected value? Think of expected value as something similar to the mean value, right? You're saying what is the approximate or average shortage that you are going to have during replenishment cycle. Now, what does this mean? This means that if I am going with the policy of having a reorder point of 20, on average, because I don't know what the demand is going to be, right? For multiple periods of demand that I'm going to have, what is the average shortage that I'm going to have, given that my demand follows this distribution with mean demand 15 and sigma is 5. That is what we are trying to find. Now, this formula of expected value is calculated as x into P of x using a discrete distribution. But whenever we look at normal distribution is not a discrete distribution. It is what we call a continuous distribution. Now, for continuous distribution, expected value is calculated as integral of x f of x dx, right? Now, this f of x is what we call as the probability density function. This probability density function is nothing but the function that gives this particular shape, right? This shape, right? Now, shape is nothing but the height achieved by this curve at different points, right? If this is the height, this is the height. Imagine drawing multiple bars like we have drawn the histogram and we are trying to join that. So this is what this probability density function is, right? Now, the probability density function, once we get this is a continuous distribution. Think of any other continuous distribution as well, right? So let's say you have uniform distribution, you have exponential distribution. For all of them, there is a corresponding probability density function. Now, if you recollect the formula that we are given for expected shortage during replenishment cycle, we call that as integral x is equal to ROP to infinity x minus ROP f of x dx, right? Now, first, the integral is coming because we are looking at expected value, which is nothing but like an average, right? then f of x dx is coming because of this particular reason, right? We are calculating the continuous distribution expected value. Why are we not using x and why are we using x minus ROP? Because we are interested in calculating not the average of this value, but the average corresponding to this region. Now, this region is nothing but the difference. If I'm interested in shortage, we are seeing the difference is demand minus ROP. Now, because demand is uncertain value, we are representing that by x. Now, as we discussed, when will we have an expected shortage? An expected shortage will only happen when your demand is more than the reorder point. If your demand is more than the reorder point, the amount of shortage that you're going to have is x minus ROP, right? Now, what is the shortage when you are going to have your demand is ROP minus ROP, which is 0. So if your demand is 20 and ROP is 20, your shortage is 0. But if your demand happens to be 20.5, let's assume that it is not a discrete value, but let's say it's something like number of liters of petrol or number of kgs of sugar. So that is the value, right? So if that is 20.5, then you have a shortage of 0.5. Corresponding to that, this f of x is, as I mentioned, is giving the height of this particular distribution. The height, if you recollect, is nothing but the frequency distribution or the probability. So corresponding to each of these particular values that you see over here, which is to the right, what is the probability, right? And that probability is getting multiplied over here, which is giving us, think of it almost like a weighted average, right? So we are getting a weighted average, which is what is represented as ESC. And the good thing for us is because, as I mentioned, whenever we have these nicely looking shapes, which are what we call as the distributions, we can convert this formula into something that we can easily work with. And that is where this particular formula of minus safety stock into 1 minus capital Fs SS by sigma L plus sigma L into Fs SS by sigma L is coming in. Now, as we mentioned, SS is nothing but safety stock. Sigma L was standard deviation during lead time, which we calculated as sigma root L, right? Which is what we had calculated. Once we have this, if you remember this particular thing, safety stock, as we can look from the previous calculation, is Z sigma root L. So if I write this as SS by Z sigma subscript L, then Z is nothing but SS by sigma L. So that means this value is nothing but the Z value. So this is my Z value. Now, the smallest over here, SS is representing the safety stock, sigma L is standard deviation during lead time. Now we know that this is Z value. The small s is representing that this is a standard normal distribution, right? Now, the standard normal distribution means that we are looking at a particular special type of normal distribution with mean 0 and standard deviation 1. Right? This mean 0 standard deviation 1 is a situation which looks something like this, where imagine on the left hand side you have minus infinity and plus infinity. We are saying that this particular thing, mu is 0 and sigma is 1. Sigma or sigma square, whatever you want to call it, because square of the variance is also 1, right? So that is what we are showing over here. Now, the good thing is this particular thing can also be represented in Excel. Once we have your safety stock, right, we can represent this as 1 minus norm dot s dot list, right, corresponding Z value, whatever is Z value. And this capital F is what we refer to as the cumulative distribution function. The cumulative distribution function is corresponding to a particular z value. Corresponding to a particular z value, what is the left-hand side value of it? So what is the entire area to the left of this particular thing? That is what this CDF is representing, which is represented by capital F, right? So this can be written like this. So in Excel, if you write this particular thing, this is basically representing true. This is for cumulative distribution, and sigma subscript L, or you can write it as sigma root L, and this multiplied by norm dot S dot test Z value and 0. Right? So this is how we'll write this particular thing in Excel. Right? So we have seen that example. You can go back and look at that particular example, which is there in your spreadsheet that is given to you. You will be able to better understand it. Now, another way to remember what is this fs, small fs, if I give you an example, let's say for example, let's say I'm saying that the z value that you calculated is let's say 0.8, right? Now corresponding to 0.8, let's just as an example I'm giving, let's say corresponding to 0.8, the height, so this, because this is 0, this is 0.8. If let's say this particular 0.8 height at this particular point is maybe let's say 0.2, then f of 0.8 is going to be 0.2, and because we said normal distribution is symmetric, and this area to the left of it is, as you know, this is 50%, and let's say up till this particular point, if this value is, let's assume, this might not be exactly correct, but let's assume if this is 30%, f of 0.8 is just going to be, because this is to the left of it, 30% plus 50%, which is going to be 0.8 or 80%, right? So that is how you will calculate these things, right? Now, you don't have to do any of this. Excel can directly do it for you. That's what we are going to look at. Okay, this is the entire discussion regarding your segments, the continuous preview. Now, the ESC was actually calculated for us to get to another measure of service level, which we call as fill rate. Now, we said that fill rate is the percentage of the demand during any demand period fulfilled using, this is fulfilled using on-hand inventory, right? Now, while I have mentioned any demand period, you can, because we might have multiple demand periods, you can say this as the average demand period, right? Over multiple periods. So you can take an average of the percentage demand fulfilled. So for example, if we have 3 such instances where in the first case I have inventory of 90, 90 and 90, right? And I had a demand of 100, 90 and 90. So over here, if that means that here I had let me take 4 instances where here again my demand was 100. So here I have 90% fill rate because my demand was 100 and my inventory was 90, on-hand inventory, right? On-hand inventory is 90. Here I fulfilled 100% of the demand. Here also I fulfilled 100% of the demand. Here again 90% of the demand. Then it would be nothing but a sum of all of this, which would be, or average of all of this, I take an average of all of this particular thing, it would come out to be 95%, which will be my fill rate. Okay, so that is what I'm looking at. And the good thing is this fill rate can be calculated from, fill rate is usually represented by small fr, which is represented by 1 minus expected shortage during the replenishment cycle by Q. Q is the quantity or economic order quantity that we are ordering every time. Right? So we can also refer this to as EOQ, because the answer to the question how much to order is EOQ, which is Q. Right? Sometimes also represented as Q. Now, if you also think about fill rate is 1 minus whatever we have not fulfilled, right? So if we look at this, why is this 90%? Because we were not able to fulfill 10% of the demand, right? So that is the reason. That's the reason why this 1 minus ESC by Q is coming. ESC is basically whatever fraction of the demand that we are not fulfilling. That is what we look at. All right. So this is about the continuous review. Periodic review, we are not going to go into the detail of how we get the entire formula over here, but just for your understanding, again, for periodic review, we make the assumption that demand is following a normal distribution. The demand is following a normal distribution. Now here, we are saying the demand is following normal distribution. Because we are seeing that our inventory is not tracked continuously, we assume that we are going to review our demand or our inventory every R weeks, right? R weeks, R days, whichever you want to say, we are going to look at demand every R weeks. Now, that means that we are leaving situations where our entire inventory is kind of left to manage for itself, right? So if we take this particular situation, what we are saying is that if I have, if my demand happens to be like this, squiggly like this, now this is the time period when I first check my inventory, right? So this is, and after another R, so that is, and the time becomes 2R, which is the difference between this is R weeks, right? So this is the Rth week, this is the 2R week, right? So the difference between this is 2R weeks. Between this, there could be any situation that could happen, right? That is, there is no concept of reorder point over here, right? So there could be any such situation that could happen over here. That is, as we discussed, demand could be so drastic that before the next visit happens itself, your demand could entirely be so high that you, even before you checked it, your inventory is gone. Now, in such kind of cases, it becomes very, very difficult because you are going to be very reactive to such kind of situations. Now, this is the reason why in periodic review, to avoid such situations where you might lose out on this, what you are going to do is you are going to end up having higher inventory. Now, again, we try to answer the question how much to order and when to order. Now, the answer to the question how much to order happens to be what we refer to as the order up to a level. Now, the order up to a level, this is a roundabout way of saying how much I'm ordering. So what we are saying is, think of it like a tumbler which has the highest capacity, which is over here, right? Now we are seeing that if we drink water and the next period the water happens to be over here, the maximum amount that I can fill it up to is this level, right? So the amount that I'm going to fill is this much. So let's say this happens to be 100 ml and you drank, let's say 80 ml, and at the time when you are looking at your inventory, it happens to be 20 ml. Because the highest level is 100 ml, you can only fill up 80 ml. So this happens to be the amount that you are filling. And if the next time when you check your inventory, it happens to be 50 ml, because the highest is 100 ml, you are going to fill only 50 ml, right? This bar that we are sitting over here, this bar is what we refer to as the order up to level. And there is a formula for this order up to level, which is what we write as mu into L plus R plus Z sigma under root L plus R. Now this is what, if you recollect, similar kind of formula was there for reorder point in continuous review, except that there the formula was mu into L and Z sigma under root L. Here, the new thing that got added over here is this plus R and plus R, right? Same way as we have mentioned Z sigma under root L there as safety stock, in the periodic review, Z sigma under root L plus R is the safety stock. Now, you can clearly look at this and stop the video and maybe compare it with the previous value of the safety stock in continuous review, that the safety stock in the periodic review is much more than the value which is in the safety stock for the continuous review, because there it is just Z sigma under root L, here it is Z sigma under root L plus R, right? The extra R is increasing the safety stock, which means that our inventory that I'm carrying is going to be higher. Now, it is intuitive for us to understand why is that the case, because the reason why that is higher is because we are left vulnerable for this R weeks where we are not checking our inventory, while in the case of continuous review, we are continuously checking our inventory. So this is the cost of not having due diligence in checking our inventory, that we are carrying higher amount of inventory. Now, this is the answer to the question how much to order. If you want exact answer of how much to order, then this is going to be OUTL minus I. I is the inventory at the time when we are ordering. So this is like this 20 ml and 50 ml, right? So OUTL happens to be 100 ml minus 20 ml, which is 80 ml, is the answer to the question how much to order, right? This is the answer to the question how much to order. Now, to be more precise, we can refer this as maximum of OUTL minus I comma 0. Why is this the case? Think about it and you will be able to understand it. Right? This is the answer to the question how much to order. Now, when to order, in this particular case, happens to be every R weeks, right? Now, you can say that we need not necessarily order every R week, right? But we are checking our inventory every R weeks. That means even if we are ordering 0, we just say that I ordered in that rth week, but I ordered 0. So that is a different way of saying that we are ordering every R weeks. Whether we are ordering a 0 value or a positive value, we are saying that we are ordering every R weeks. So this is the policy that we follow when we have periodic review, right? So in this particular case, unlike what we have discussed over here, cycle service level still happens to be the same thing. That is, the Z is representing the cycle service level. So there is a example which is given for you to understand how do you calculate the service level back if you are given OUTL and other things, right? We can look at that. Then the concept of fill rate is slightly different over here. Unlike the continuous review, where we are ordering the same amount every time, here, because the inventory at the point when you are checking is going to be different, as we have seen over here, we cannot calculate fill rate like we have using the formula which is given over there. Now, when we are discussing the case of Scientific Glass Incorporated, we will find one technique which we can use to calculate something like your fill rate for periodic review as well, right? You understand that? And we'll go into more detail. I hope this video will be useful for you to recollect the concepts related to continuous review and periodic review that we have discussed. and also appreciate what we have discussed in the class in the last session. Thank you.